Okay, we're continuing on with some sample text questions for lesson 3 in the radicals unit. So question 10, we'll do A here. So A has two radical, all of these in question 10 have two radical terms. What's nice about A is that that's all it has. So if you have two radical terms, put one on each side. In this case, that's the way it already was. And it's really quite easy because there's no extra term when you're squaring both sides. So when you do square both sides, you just get the radicands. So here, you're just going to get z plus 5 equals 2z minus 1, and that's an easy question to solve, right? You've been doing that since junior high. So subtract z from both sides. And add 1 to both sides, so z equals 6. When you take a look back at the restrictions here, we know z has to be greater than or equal to negative 5. And then from here, z has to be greater than or equal to 1/2. So 6 satisfies that. But again, you do want to check because that's only sort of the first part of checking. So it does satisfy that part, but then you do need to verify. So the left side, substitute 6 in, so you get root 11. The right side, substitute 6 in, and you get root 11. So the left side equals the right side. So z equals 6 is the solution to that equation. Now in C, you have two radical terms and you have two constant terms. So I'm just going to copy out here. When you have more than just two radical terms, you want to simplify any other term. So I'm going to add 3 just to make it positive constant term. So when I do that, I have 5r minus 9 on the left, and I'm going to have r plus 4 plus 1 outside the radical. I can't do any more to simplify that equation, so now I square both sides. But when I square both sides, this ends up being 3 terms because it's a binomial squared. So the left side is easy. The right side, though, when you square a binomial, so remember back to, a plus b squared, when you learned this in Math 10, is a squared plus 2ab plus b squared. Or you can show it out the long way and use FOIL. But the first term squared really just gets rid of the radical sign. Then the product of the two terms doubled will be 1 times this doubled is 2 times that. And then the second term squared is 1. So now I'd like to just take a step to collect like terms. So 4 plus 1 is 5. And then notice how we still have a radical. So it's almost like a new question starting. We have to get rid of that radical sign there. So we need to isolate this. So we're going to subtract r from both sides and subtract 5 from both sides. So that's going to be 4r minus 14 equals, those go away, so 2 root r plus 4. And then if 2 divides into everything there, I will do that. Makes it, again, simpler. So that will give you 2r minus 7 equals root of r plus 4. And now we can square both sides on this. And when we do that, we have to square this binomial. So that's 4r squared minus 28r plus 49 equals r plus 4. And it's a quadratic, so you want to get everything to one side. So I'm going to bring everything to the left. Okay, and then we have to solve by factoring, or it could be quadratic formula. Most times it'll be something that can be factored. So we are looking for two numbers. So I kind of do a combination of trial and error and decomposition. So I start with the decomposition method of finding two numbers that multiply to the product of 4 and 45, which is 180. And then those two numbers have to add to negative 29. So you can use your calculator. So 1 and 180 isn't going to work, obviously. 2 and 90, 3 and 60, 4 and 45, 5 and 36. So we're kind of getting close. We know that they have to add to a negative and multiply to a positive. So they both have to be negative. So what else? 6 and 30. So if those were both negative, no. 7, 8, 9, and 20. There you go. Both negative. So now I don't just put those in because this is 4r squared. So I have to think about, I have to get negative 9r and negative 20r from the outside and inside. So this is my method of trial and error. So if so the only way to get 9, I can't split this up into 2 and 2 because 2 doesn't go into 9. So it's going to have to be 4r and r. And so then my outside would have to give me negative 20 because my inside my insides can't. So negative 20, that means that has to be negative 5, and this would have to be negative 9 in there. So now my solutions are 9/4 and 5 possible solutions. Go back to your original here. So we know that r has to be greater than or equal to 9/5 here, and r has to be greater than or equal to negative 4. So for sure, it has to be greater than or equal to 9/5. It's negative 4 less than it. So negative 9/5, positive 9/5, right? Yeah. So that's what, 1 and 4/5. This is 2. So these satisfy both of those, but again, you need to verify. So I'm going to check. So left side, right side. First, I'm going to check 9/4, and I just need to look at my equation again. So it was 5r minus 9 minus 3. So 5 times r minus 9 minus 3 on the left, and the right was root r plus 4 minus 2. So r here, I can put in that 9/4. So this is going to be what? 45/4 minus 36/4, which is, what's that? 9/4, which is 3/2 minus 3, okay, which is negative 3/2. And this, so that's 9/4, so that's going to be 9 plus 16/4, which is 25/4, underneath the radical, which is 5/2 minus 2, which is 1/2. Left side does not equal to the right side. Okay, so then we check on the next root. So r equals 5. And that's 5 times 5 minus 9 minus 3. 25 minus 9 is 16. So 4 minus 3 is 1. And then here we'll have 5 plus 4 minus 2, which is root 9 minus 2, which is 3 minus 2, which is 1. So 9/4 is extraneous. Your solution is x equals 5. Okay? And again, you can check your calculator. I think I entered already. So again, you can enter the left side into y1, right side into y2, What I did was get everything onto the left side and then the right side 0. So really I'm looking for an x-intercept. So if I graph that, there's my graph. And now if I do my second trace intersect, I will get 5. Okay, no other place will it cross. So that's that one. And then question 16, this is kind of a word problem. So it says 2 more than the square of a number n is equal to the number. Model the situation using radical equation and then determine the values algebraically. So they're already telling you the variable is n. So it says 2 more than, so that means plus 2 to something. More than means it puts the 2 to the right. Not that it matters with adding, but for subtracting it does. In any case, 2 more than the square root of a number, so there's square root of n, is equal to, is always means equals, to the number. Okay, that's what we have to solve. So we know here n has to be greater than or equal to 0. We're going to bring the 2 over. So it'll be root n equals n minus 2. And then square both sides. Okay, so that's just going to give you n. Squaring n minus 2 is n squared minus 4n plus 4. Then we want to, it's quadratic, so get one side equaling 0. Okay, and then let's see if we can factor that. So it's a simple trinomial, two numbers that multiply to 4, add to negative 5. So they're both going to have to be negative. Negative 4 and negative 1 work. So n equals 4 and 1. Okay, and so they both satisfy this, but let's verify into our equation. So n equals 4. So that's going to be root 4 plus 2, which is 2 plus 2, which is 4. And the right side is 4. So that works. And then in the other, root 1 plus 2 is 1 plus 2 is 3. And the right side is n, which is 1. That doesn't work. Okay, so this is extraneous. Your solution is n equals 4. Okay, so those are another couple of questions to help you with your homework.